Let's solve some problems. Okay, let's take up the first one. Let's say we have been given a point. Position vector is 0, 2, minus 3, and we have been given a vector which is 2i minus j plus k. So what we have to figure out is the equation of the line of passing through the point A and parallel to the vector alpha. Now, if you know the equation, pretty straightforward. So you just have to say x minus 0 by 2, right? 2 from here and 0 from the point through which it is passing. Y minus 2 by minus 1. Z minus 3. So minus 3 by 1. And if we simplify this, we get x by 2 is equal to y minus 2 by minus 1 and z plus 3 by, as I said, pretty straightforward. Now let's look at the second problem. Again, we have been given a point, right? So let me write it as a question itself. Equation of a line. So we have to find this passing through 1, 2, minus 1 and perpendicular to x by 1 equal to y by 0 is equal to z by minus 1. So this is line 1, also perpendicular to another line, that is x by 3 equal to y by 4 is equal to z by 5. Let us say this is L2. Now by looking at this equation of the lines itself, we know that the drs of L1 and L2 are 1, 0, minus 1 and 3, 4, 5. Yes. Now let L, M and N be the direction cosines of the required line. Okay. Now, since the required line is perpendicular to L1 and L2, that implies that 1 times L plus 0 times M plus minus 1 times N is equal to 0. What we have done is we have multiplied the dr of L1 and the direction cosine and summed it up, and that summation will give you 0. Okay. Now similarly, it is perpendicular to the other line also. So 3L plus 4M plus 5N is equal to 0. So let's remove all the brackets. L minus N equal to 0. 3L plus 4N plus, this is plus 4N plus 5, this is M. 5N is equal to 0. Now how do we solve this? We can solve it in many different ways. The simplest, which I think is the simplest, is this: 1, 0, minus 1, 3, 4, 5. This is the determinant, right? So when we solve it, this is what we get: L by 0 minus into minus plus 4 equal to minus M by 5 ones 5 minus 3 times minus 1. So minus minus plus. So plus 3 is equal to N by Again 4 minus 0. So let's simplify this. L by 4 is equal to, now numerator we will not have a negative number, so this becomes minus 8 n by 4. So here remember, numerators are all direction cosines, denominator are all direction ratios. So 4 minus 8, 4 are the direction ratios of the required line. Okay, so we can simplify those DRs by saying DRs of a required line is 1 minus 2 1. So now the equation of the required line with DRs and passing through what? Through the point 1 2 minus 1. And we know straightforward this formula for this. X minus 1 by 1 is equal to y minus 2 by minus 2 z minus 1, minus into minus, plus 1 by 1. So this is the equation of the line which passes through 1 2 minus 1 and is perpendicular to the given two lines. Yes, okay. Now let's take the next problem. Now the third problem is we have to figure out the equation of the line passing through 3 2 minus 8 and perpendicular to 3x minus y minus 2z is equal to 2. Now what is this? This is a plane. Okay, so now the required line perpendicular to a plane, yes, the normal to the plane is also perpendicular to the plane. What does that mean? It means that the required line is parallel to the normal to the plane. Yes, that means the DRs, direction ratios of required line, is equal to the DRs of the normal to the plane. That means DRs of the required line is nothing but 3 minus 1 and minus 2, right? These are coefficients, 3 minus 1 minus 2. Okay, so therefore the required line passing through 3 2 minus 8 and having DRs of 3 minus 1 minus 2 is x minus 3 by 3 is equal to y minus 2 by minus 1 is equal to z minus minus 8, that is plus 8 by minus 2. So that is the equation of the line that passes through this point and is perpendicular to the given plane. Okay, let's look at the next problem, fourth one. We have to figure out the equation of the line passing through 2 points, that is passing through 2 0 minus 1 and 3 minus 5 8. So let us say this is A and this is A, or we can also say this is x1 y1 z1 x2 y2 z2. Formula for this again pretty straightforward, x minus x1 by x2 minus x1. Similarly y minus y1 by y2 minus y1. Similarly z minus z1 by z2 minus z1. Now it doesn't matter whether you make A as x1 y1 z1 or you make B as x1 y1 z1. Okay, so I'll do it both ways. and we will see the result. So in the first case, this would be x minus 2, y minus 0, z minus 1, so plus 1, divided by now x2 minus x1, right? So that is 3 minus 2 minus 5 minus 0 and 8 minus 1, that is plus 1. So this implies x minus 2 by 1, y by minus 5 and z plus 1 by 9. Now let's change the order. Instead of saying this is x1 y1 z1, let's say this is x1 y1 z1 and this is x2 y2 z2. So in that case, what happens? What we get is x minus 3 by 2 minus 3, y minus 5, that is y plus 5 by 0 minus 5, so that is 5, is equal to z minus 8 by minus 1 minus 8. So when we simplify this, we get x minus 3 by minus 1 is equal to y plus 5 by 5 equal to z minus 8 by minus 9. Yes. So if you graph it, you can use GeoGebra and just type this and you will find that they both represent the same line. Okay, so that is figuring out straight lines. That's it. Bye.